See here. We are talking about refraction at a prism beta. I told you for the refraction at a prism, any two plane surfaces should be making an angle.
Yes,
then
sir.
that will be the called as of your prism.
Prism.
The prism can be of an hexagon, pentagon, anything basically.
Okay, sir.
Isn't it? Now, if this is your triangle or prism A, B, and C, in which this ray of light is being incident beta, that is K to L is angle of incidence. If this prism would have been not present, the ray of light might have been traveled in a straight line like this.
Yes.
Isn't it? But due to the prism, what happened? It has been bended from L to M. So it is now in denser medium of refractive index mu.
Yes, sir.
The ray of light is going from denser medium to rarer medium. So it bends away from the normal. That is nothing but equal to your Mn. Now the total ray of light through the refraction will be equal to how much beta? K to L, L to M, and M to N.
Yes.
And this is the final refracted ray. M to N is the final refracted ray. If I extend this refracted ray in the backward direction, it is meeting somewhere at a point P on the line of the K, L, and as well as of your Q. The angle made by the angle of incident with the refracted is known as of your deviation.
Yes, sir.
Isn't it? Now this is the first refraction beta R1. This is a refraction at the second surface. That is nothing but R2. The points where these two normals are meeting, that is making angle theta. This R1, R2, and theta must be equal to 180 degrees. Isn't it?
Yes.
If this is I1, this total should also be equal to I1.
I1, yes, sir.
Then here it R1 is removed, but this remaining angle will be I1 minus R1.
Yes, sir.
So here also it should be equal to your I2 because this is your I2. This should also be equal to your I2. So this will become here how much for me? I2 minus of your R2.
Yes, sir.
So now this deviation, see, if I'm considering the triangle QPN, consider the triangle right now for us right now, QP and as well as of your N. This one.
Yes,
QP and as well as of your N. This is your normal. Okay. Q, P, and E. This is a deviation. So in the triangle P, L, and M, I can write this deviation dou will be equal to this angle of your PLM plus PML.
Yes, sir.
Isn't it? So the deviation will be equal to how much? I1 minus R1 plus I2 minus R2. All the I1 terms I am taking on one side beta. So deviation will be equal to I1 plus I2 minus of your R1 plus of your R2. So this is the deviation formula actually in planes of I1, I2 and R1 and R2. Is it clear?
Okay, sir. Yes, sir.
Now, next one, see. Now consider the quadrilateral beta. Now in the triangle OLM, I told you already, in this triangle OLM, this total angle should be equal to 180 degrees beta.
Yes, sir.
So angle theta plus angle R1 plus angle R2.
Yes,
angle theta plus angle R1 plus angle R2 is 180 degrees.
Yes,
now in the quadrilateral ALOM, this is a quadrilateral. These two angles and these two angles must be same.
Equal.
That means angle L plus angle M is 180. Angle A plus angle O will be also 180. 180. Now equation, using this equation 2 in this one beta, angle A plus angle O is 180. In the place of 180, you can write angle O plus of your angle R1 plus angle R2. So angle O and angle O will get cancelled. So angle R1 plus angle R2 will be equal to your A. That means angle of your prism will be equal to R1 plus R2. Very important formula.
Yes, sir.
Angle of your prism is equal to R1 plus R2. Now substituting this 3 in equation number 1. This is your equation number 1, what we have got.
In place of
R1
plus R2, we'll get
I1 plus I2 minus R1 plus R2. This R1 plus R2, I can take it as
A.
of your A.
Yes, sir.
So deviation will be equal to I1 plus I2 minus of your A. This is your deviation formula.
Okay, sir.
Is it clear?
Yes, sir.
Sure. Next one. If mu is the refractive index of the material beta, then we can apply the Snell's law at the two refracting surfaces.
Yes, sir.
At this surface, that is nothing but equal to your AB. I can apply the Snell's law. Then I can apply the Snell's law to your AC. So here it is I1 R1 and here it is your I2 and R2. So see here, if I'm applying the Snell's law for the surface AB, refractive index of 2 with respect to 1 will be equal to sin I by your sin R. When angles are very small, I told you that sin I can be approximated to I and sin R will be approximated to R. So mu2 by mu1 is equals to sin I1 by sin R1. Angles are very small, but that will become for me I1 by R1. So I1 will become how much better? Mu into R1. Because for A, refractive index is how much better? Mu1 is equals to your 1. And yes, mu2 sir. Is equals to your mu. So mu I1 is equals to mu times mu of your R.
Okay, sir.
Okay, now?
Yes,
the same
sir.
way, Snell's law for the surface AC. For the surface AC, this one. Isn't it? Angle of refraction is taking place in this medium beta.
Yes.
Isn't it? So I can write your Snell's law right now for that one. Snell's law for the surface AC, it is mu into sine of your R2 is equals to 1 into sine of your I2.
Yes, sir.
Isn't it? So mu into R2 will be equal to I2 because sine R2 is nothing but R2.
Yes, sir.
Isn't it? Now substituting this in equation number 4. Where is your equation number 4? This is your equation number 4.
Yes,
I1
sir.
value we got, I2 value also we got. I'm substituting that in that one. So this dow is equals to I1 is mu into R1, I2 is mu into R2 minus A.
Yes,
Mu
sir.
common, R1 plus R2 minus A. R1 plus R2 is A. Again, A is common, so deviation will be equal to mu minus
Mu
1
minus
into your
1
A.
into.
For the small angle prisms, the deviation formula is mu minus 1 into your A. For larger prisms, the angle of your prisms will be I1 plus I2 minus of your A. Is it
Okay,
clear?
sir. Yes, sir.
Is it clear?
Yes.
That was about your deviation for the small angled prism concept. Now, if I'm talking about your prism formula, in minimum deviation position, the moment I'm using the word minimum deviation, I mean to say that angle of your incidence and angle of your emergence will be same.
Okay, sir.
And R1 and R2 will be equal to your R. Okay.
Okay, sir.
So
Yes.
then angle of prism will become how much better? R1 plus R2.
Yes, sir.
So A is equals to R plus R. So A is equals to 2R. So R is equals to A by 2.
Okay, sir.
So now similarly, equation number 4. Deviation is I plus I minus A because I1 plus I2 kada akkada.
Yes, sir.
Then both of them are same in minimum deviation. I1 and I2 is equals to I. So it is 2I minus
2i minus.
So deviation, this minus A will go here. So dm plus A is equals to 2I. So I is equals to D plus A by 2. This deviation I'm writing as capital D.
D. Okay,
So
sir.
I is equals to A plus D by 2.
Okay, sir.
A is R by 2 and I is A plus D by 2. So using this
Yes, sir.
Snell's law, mu is equals to sin I by sin R. This is sine. I value is A plus D by 2 divided by sine of your A by 2. Clear?
Yes, sir. Sine. Yes, sir.
This formula is known as of your Prism formula. Mu is equals to sine A plus D by 2 divided by sine of your A by 2. What is A and what is D beta?
Sir, A is R1 plus R2, sir. And D is the deviation.
Deviation. And what is the name for A? A is nothing but what? Angle of prism.
Angle of prism. Yes, sir.
And D is your minimum deviation.
Yes, sir. D. Down.
What is the condition for minimum deviation beta?
Sir, I1 equals to I2 and R1 equals to. Yes, sir.
Very good. Is it clear?
Yes, sir. Yes, sir.
Cases today. If the light is being
Sir,
incident normally on the first surface.
one doubt, sir. Sir, in the previous page, sir, like the final formula, can't we cancel sine and sine, sir? Okay, sir.
Same untene cancel cheyagలుగుతాం కదా.
Okay.
It is
Yes,
sin
sir.
45 and it is sin 30. How can you
We
cancel?
can't. Yes, sir. Okay, sir.
Clear? Chalo.
Yes, sir.
The deviation through the prism is maximum when I1 is 90 degrees beta.
Okay, sir.
So deviation is maximum when I1 is 90 degrees. So maximum deviation is 90 plus I2 minus of your E. Okay?
Yes, sir.
Chalo. Now let us try to quote the guesses. If the light ray is incident normally, that means normally means on the surface, then angle of incidence will become how much? 0.
0. Yes, sir.
And R1 will also become for me how much? 0.
0.
So A is equal to R1 plus R2. R1 is 0. So R2 is R. So A will be equal to R2. And deviation formula is I1 plus I2 minus A. I1 is 0, I2 minus R2. So deviation will be I2 minus R2.
Okay, sir.
Okay. So next one. For normal incidence, we stopped yesterday here. Now see, for normal incidence means what? If the light ray is emerging out normally, if the light ray emerges out normally on the second phase. This is your second phase beta. So now
Yes,
see,
sir.
this is going normally away. So when it is going normally means, what is the first condition beta? I2 will be 0 and R2 will also be 0 kada.
Yes, sir.
First figure la, if this is your normal, if this I2, if I go on take on the normal, what is happening to the I2? I2 will become slowly 0.
0. Yes, sir.
So then R2 will also become 0 na?
Yes, sir.
Because when there is no I2, there is no
R2.
R2 at all.
Yes, sir.
So right now for that one, R2 is also 0. So therefore angle of prism will be equal to how much beta? Therefore angle of your prism is R1 plus of your R2. So A will be equal to your R1 plus 0. So A will be equal to your R1.
Yes, sir.
Isn't it? Now what will be the deviation beta? Can you tell me? Deviation dow will be equal to I1 plus of your I2 minus A. This is actual prism kada?
Yes, sir.
Actual deviation formula. So now in this one I can write here
I2 and R2 are
So
0.
this one is nothing but your I1. I2 value is 0 minus of your A. That means this
R1.
will become for me I1
I1
minus A.
minus A.
Now
Yes,
what
sir.
is the value of A?
R1, sir.
R1. So it is deviation is equals to I1 minus of R1. I can even write like this. Or deviation, if angle of prism is given, it is I1 minus of your A. Clear?
Yes, sir. Yes, sir.
Chalo.
So this is for normal when it's coming out.
Normal
No?
emergence. Normal
Normal.
emerge అయిపోతుంది final rate. Normal emergence.
Okay, sir.
Okay. The next one. For grazing incidence. For grazing incidence. Grazing incidence means it is grazing the surface of your prism. When it will graze the surface of the prism, can you tell me? Now, when this ray will graze on the surface, when I1 slowly increases
Increases.
and
Yes, sir.
become
It goes straight
90
up. Yes,
degrees,
sir. 90.
isn't it? If I1
Yes,
is
sir.
becoming 90 degrees, then it will
It will
graze the
graze.
surface,
Yes, sir.
isn't it? So if I'm drawing the diagram for this one, so this one is your prism, this one is your prism, and this is your given condition. And this ray of light is grazing on the surface. Ante దీని పైన ఇట్లా కదా,
Yes, sir.
isn't it? That means with respect to normal, ఇది normal అనుకుందాం.
Yes, sir. Fully
Is
90
it?
degrees it is.
So with a normal, this will be 90 degrees.
Yes,
This is
sir.
your N, and this is the ray of light which is been incident. So this is your angle of your prism. Now, so for this one, what is I1 beta?
90 degrees, sir.
90 degrees. I1 is equals to 90 degrees. So if I1 is 90 degrees means I2 will, R1 will become for me what? Critical angle,
Yes, sir.
isn't it? So if angle of
Yes.
refraction I1 is becoming 90 degrees means R1 should be equal to critical angle.
Critical
Then only
angle.
it will
Yes.
undergo the refraction. So angle of your prism will be equal to how much beta? R1 plus R2. Oh, no?
Yes,
So
sir.
this one is A is equals to R1 is C plus
C
of
plus.
your R2.
Yes, sir.
C plus of your R2. Clear?
Yes, sir.
Chalo. Now tell me what will be the deviation formula beta? Deviation dou is equals to I1 plus of your I2 minus angle of your prism here. So what is I1? I1 is 90.
degrees.
I1 is 90 plus of your I2.
I2 is also.
Keep,
Sir,
I2
I2.
is 90. I1 is 90, na?
Yes, sir. Yes.
I don't know the value of I2. So I'm
I2.
keeping that one
Yes,
I2
sir.
as it is. Minus A. A is equals to how much better? C
C
plus
plus
of
R.
your R2.
Yes.
Okay, na?
Yes, sir.
I1 is 90. So this one is C plus of your R2. Clear?
Yes, sir.
This
Yes,
is
sir.
your deviation. Dou is equals to 90 plus I2 minus C plus of your R2. Is that clear?
Yes, sir. Clear, sir.
This is for what? Grazing incidence. Now if I'm talking about your grazing emergence, for your grazing emergence, for your grazing emergence, because this all will be in the numericals beta for you while doing. So at that time you can't use this much of concept for doing the problem. So if you do it right now only, you will get an idea how to write the answer very faster way.
Okay, sir.
Okay, numericals are compulsory, Nico. It is been given in the numerical
They'll
sheet,
mention,
not
right,
in the,
sir, what?
yeah. There directly you can write the answers for that time. You will not waste the time there much. Okay.
Yes.
Now see, emergence means it is going out like this, isn't it?
Yes,
And this
sir.
will be the normal somewhere like this. This will be the angle of your prism here. So here I2 will become how much better? 90 degrees with your normal. So this ray of light is emerging out. So for this one, what is the value of your I2 beta? I2 is equals to 90 degrees. That means R2 will be equal to critical angle. Ante kada?
Yes.
Because you're going from denser to rarer. If I2 is becoming 90 means angle of incidence, that is R2 must be equal to C only, na?
Yes, sir.
So A will be equal to R1 plus R2. Because for this surface, R2 is your incidence. Ante kada?
Yes, sir.
R2 is your incidence. You see here right now. I'll show the first diagram. R2 is your incidence for this one, and I2 is your emergence. If I2 is making this 90 degrees, ante this I2 R2 must be equal to what better? Critical angle kada?
Yes, sir.
Because in the critical angle, if you know that an area of light is going from denser medium, if angle of refraction is becoming 90 degrees, then only the critical angle concept will come. Na?
Yes.
Gurtunda marchipoyava.
Gurtun, sir.
If it is greater than I, angle of critical angle of incidence is greater than C, then the ray of light will come back into the same medium. So that will be the concept of what? TIR.
Yes, sir.
Isn't it?
Totally.
So, total internal reflection. Now what we are talking about right now, for grazing incidence, A is equals to R1 plus R2. That means A is equals to R1 plus R2 will be equal to your critical angle. Clear?
Yes, sir.
Number B, deviation. Deviation dou will be equal to your I1 plus of your I2 minus of your angle of prism. I1 is no doubt as it is I1 plus I2 will be equal to 90 degrees minus A will be equal to R1 plus of your C. So this will be the deviation.
Okay, sir.
Clear?
Yes, sir. Sir, so
Clear?
basically, for grazing incidence, it is 90 plus I2.
I1 is 90
Yes,
and
sir.
R1 will be critical
Just
angle.
switching the
Yeah, just
values, sir.
switching the formula. That's it. There it
Yes, sir.
is I1 is 90 and here it is I2.
Yes, sir.
Okay.
And there R1 is C and here R2 is C.
Yeah.
R2 is critical angle. Yes, sir.
Okay. Sure. Now I'm doing little bit a question type of a relation only, but still we'll try to write as a few theory only. See the condition. If a light ray, if a light ray incident normally, if light ray is incident normally on one face of the prism, on one face of your prism, and the emergent ray ray grazes from second phase. Understand the terminologies. I told you all of them.
Yes, sir.
Second phase of your prism. Then what all the cases possible as I told you previous one. So
Sir,
I'll
so
try to draw
first
the
is,
diagram. Yeah. So this is your triangle.
sir, R2 is equals to C, sir.
Now first tell me what is this angle of incidence. Ray of light is incident normally on one face. That means this is a ray
Zero,
of
sir.
light which is incident on the surface normally like this. So
Zero,
that
sir.
means it will incident on this one. So
Yes.
what is zero? What is zero? I1
Sir,
is zero, no?
yes, sir. I1 is zero, sir.
I1 0 and R2.
Sir, R2 is 90 degrees. Sorry, C, sir. Critical angle because it's grazing.
This is grazing here.
Yes, sir.
Clear?
Yes, sir.
So if I'm writing here right now, along the normal, and here this will be the critical angle. So this will be your C, and this will be your 90 degrees. This 90
Yes, sir.
degrees will be I2. And
Yes, sir.
here I1 will be 0, and R1 is
R2
also
also.
0,
R1 also, sir.
isn't it?
Yes,
That
sir.
means if I'm writing A is equals to R1 plus of your R2, angle of your prism A, then A is equals to how much it will be better? Critical angle.
Yes, sir. Critical angle.
Because R2 will be equal to C, gada.
Yes, sir.
R2 is C and R1 is 0.
Yes, sir.
Clear? Then tell me what will be the refractive index. Mu is equals to 1 by your sine C. That means that will become for me 1 by your sine of your A. You can get
Yes,
the
sir.
refractive index of that prism,
Yes, sir.
isn't it? Now tell me what will be the angle of deviation for this one. Deviation dou will be equal to your
I1
I1
is
plus of your I2
I2 is 90.
minus of your angle of prism. So I1 is how much?
90
0.
minus.
I2 is how much for me? 90. Minus angle of your prism is how much for me? C. That means answer
Yes,
is
sir.
how much for me?
90 minus C, sir.
90 minus of C will be deviations. This
Yes.
will be the questions in your numericals. Level 2, level 3 questions on type.
Okay, sir.
The ray of light is incident on this one and emergent. What is the deviation? The
Okay,
answer
okay.
will be
Yes, sir.
90 minus C. Okay.
Yes, sir.
Now, if the ray of light is normally emerging out from the second surface beta, then what
Yes,
will
sir.
be the I2 and what will be the R1?
Sir, that time I2 is 0, right, sir?
If light ray is normally emerging out from the second phase, I2 and R2 will be same, gada. That will be 0.
Okay, yes, sir. Yes, sir.
And R1 will be equal to critical angle.
Critical angle. Yes, sir.
So I can write that point here. If a light ray, if a light ray normally emerges out from the second phase, then I2 will be equal to R2, that will be equal to 0, and R1 will be equal to critical angle. Ante kada?
Yes, sir.
Okay, check. Now this is also very important condition, beta. Limiting angle of your prism. Limiting angle of a prism. So I hope you got an idea how to do the problems right now with the grazing normal incidence. Alanti terminologies unte, I hope you can do it comfortably.
Yes, sir.
Okay, chalo, let me take this one. This is your prism. Ray of light is incident on this one like this, and the ray of light will go like this, and from here this is coming out finally like this. What do you mean by this one? Tell me. This will be the angle of your incidence here. This will be the normal. So here
Yes,
it
sir.
is normal means I1 will become 90 degrees,
Yes,
isn't
sir.
it? So this will be equal to your R1. Again, this will be the normal. This will be equal to I2. I2 is again 90 degrees, and this one will be equal to your R2.
Sir, here isn't it greasing? Okay, yeah. We
The
can't.
both of them are. This is also
Both of them
grazing.
are
This is
greasing.
also
Yes, sir.
grazing. So in this one, I can say that I1 and I2, both of them are 90 degrees.
Yes, sir.
And R1 and R2, both of them will be equal
Critical
to critical
angles.
angle.
Yes, sir.
So as we know that angle of your prism is equals to R1 plus R2. That means this will become for me 2C. So angle of your
Yes,
prism
sir.
will be equal to 2C. Ante kada R1 is C. R2 is
Yes,
also
sir.
C. C plus C 2C. So A is your 2C.
Yes, sir.
Then what will be the refractive index of the prism beta? Mu is equals to 1 by your sin C.
Yes,
So
sir.
that is equals to 1 by sin C will be equal to how much beta? From this one, C is equals
A
to
by
A
2,
by
sir.
2. That
Yes, sir.
means this
Sin A
will
by 2.
become for me sine of your A by 2.
Yes, sir.
Okay, the next one, angle of deviation. Deviation is equals to I1 plus of your I2 minus angle of your prism A. That means this will become for me 90 plus of your 90
180
minus angle of
2C.
your prism A is nothing but 2C.
2C.
90 plus 90 is
180.
180. 180 minus of 2C will be the deviation.
Yes.
ఇది కూడా రేపు నీ weekend examination వస్తుంది చూడు compulsory question.
Okay, sir.
Okay, when
If
in
both
limiting
are
case, what is the deviation? It is 180 minus of your 2C. What do you
okay,
mean by limiting case?
both
If the angle of the
incident
prism for which the ray is grazing on one face of the prism, and after refraction also it grazes out from the
graces.
second
Yes.
surface. That is known as your limiting angle.
Sir, is this
Do I need
possible?
to write that statement?
No, sir. I understood, sir.
Isn't it? You got it now? It is
Yes,
the
sir.
angle of the prism for which the ray grazes on one face of the prism, and after refraction, it again grazes out
Again
from the
graces.
second
Yes, sir.
surface.
Yes, sir.
Okay. So for that one, what is the deviation? Until it is 180 minus of your
180 minus
2C.
2C.
Clear?
Yes, sir.
Is it clear? Sure.
Yes, sir. Sir, now is this possible, like practically, sir, or
Yeah, they are practically possible.
okay, sir.
This all of them are practically possible.
Okay,
Okay.
sir.
Now they, you see, you might have been got an endoscopy. You might have been seen,
Yes, sir.
isn't it? Endoscopy by the mouth or by the holes. We
Yes, sir.
generally
Yes, sir.
the what do you call that one? Pipes will be inserted, and it will
Yes,
go
sir.
in a zigzag
Checking
manner
for
inside.
ulcers. Yes, sir.
Ulcers part. So it will go in the zigzag manner in the intestine, and we can see the ulcers are there right now.
Yes, sir.
How we are able to see? Because light has been incident on that one.
Yes,
It
sir.
will
Yes, sir.
grazes out and comes out. Then only we can see the image of that one now.
Yes, sir.
This all phenomena are been applicable in such type of instruments, and even in
Okay,
you
sir.
do in your MBBS, in that also you'll be getting this all applications in radiology and in the MBBS part affiliation. Physics will come a lot there also for you.
Okay,
At that time to study the X-rays and to study the electrocardiograms up and down part affiliation. The
yes,
vectors
sir.
are very much needed, and the prism concept is very much needed. Optics concept is very much needed. If you are going to be an ophthalmologist, then complete ray optics would be very good idea for you.
Yes, sir.
Isn't it? So that all things are being based
All
upon.
the
So these are
lenses
all
we
the
require
basics related
properly,
to that.
right?
Okay, na?
Yes, sir.
So next concept, that is about your dispersion of your light. Dispersion of your light. What do you mean by dispersion of your light, beta? Splitting of
It is
your
split
white
into
light
with
into its
yes,
constituent color, isn't it? So it
yes,
is
sir.
nothing but of what? Splitting of your light. Splitting of your what light, beta? White light.
White lights.
Splitting of your white light into its constituent colors.
Constituent.
Into its constituent colors on passing through prism. Ante kada?
Yes, sir.
On passing through prism, like rainbow, isn't it? Different
Yes,
colors,
sir.
yeah, that all are possible
Sunlight is
because
white
of this
lights.
one.
So
Yeah, And this occurs due to wavelength beta. Occurs due to change in wavelength. Occurs due to change in your wavelength. Because different colors are different wavelength, na?
Yes,
So
sir.
different refractive index. And violet color will deviate through maximum value beta, and red color deviates through the minimum value.
Yes,
That
sir.
is the reason in the signals we use the red signals to
Red
stop.
colors. Yes, sir.
Red color, because the deviation of this one is very less.
Yes,
Like
sir.
say if
And
there is a
wavelength
red
is
light
very high,
here,
right, sir?
if the red light is here and there is a road here, if the deviation for the violet, if this is the light which is coming out, in this one, the red color deviation is very less. So that is the reason up to here it can go. That means any car which is being present here can see the red light. Whereas the violet color, what you are taking, the deviation of this one is more. That means it can
Very
be fall
less, sir.
here only.
People can't
So if
see
you are
properly.
coming very near only, then you can see the
Yes, sir.
violet particulation.
So
So red
basically
color
wavelength is
deviation is
high, right,
less,
sir?
violet color deviation is more.
Yes, sir. So basically red color wavelength is high, right, sir?
Yeah, wavelength will be high, inversely
So
proportional.
far places also they
Yeah.
can.
So I can write here color, violet color
Deviates
deviates
most.
maximum.
Yes, sir.
Okay. And
Yes, sir.
red color deviates minimum. Okay.
Yes, sir.
So for small angle prisms, what is the deviation formula beta? For small angles of prism, like 2 degree, 5 degree, deviation is equal to how much beta? Mu minus 1 into your E,
Into A, sir. Yes, sir.
isn't it? So this is the formula which we use large in the dispersion concept. Is it
Yes, sir.
clear?
Yes,
So
sir.
in this one, let us try to discuss the first one, that is known as of your angular dispersion. Angular dispersion represented by theta. It is the deviation in which the ray of light is being present better. Like say, if I'm taking this one as of your light through the prism, this is your prism, like this. Okay. When white light is being incident on this one, like this, it undergoes the deviation. So there will be deviation like this here with the different colors. Okay. For red and violet, yellow is taken as of your mean color. Okay.
Yes, sir.
In the absence of this prism, the light might have been traveled in a straight line like this.
Yes, sir.
ఒకవేళ prism లేకపోయింటే the light might have been traveled in that one. That is an incident ray of light, isn't it? Now here what is happening, when a ray of light is coming from this one, again it will slightly bend from the normal. Again it will be coming out like this,
Yes, sir.
isn't it? So this will be coming out like this finally. Okay.
Yes, sir.
Now see, what do you mean by the deviation beta? What do you mean by deviation? Tell me. Deviation starting lo నేర్చుకున్నాం మనం. Angle made by the incident with the refracted is known as deviation.
Yes, sir.
This is your incident light. This is
Yes,
your
sir.
incident light. And this one is what beta? Refracted light.
Yes, sir.
This is your refracted light. So angle made by the incident with the refracted ray is known as what? Deviation.
Deviation. Yes, sir.
This is your violet. This is your yellow. And this one is your red. So if I'm writing the angle made by the incident with the violet is known as of your deviation of violet color.
Yes, sir.
Angle made by the incident with the red color, this is the
Deviation
deviation
of
of
red
red
color.
color.
Yes, sir.
Angle made by the incident with the yellow, this will be the deviation of your yellow
Yellow
color.
color. Yes, sir.
Clearer? That
Yes,
means
sir.
deviation will be equal to mu minus 1, I can write.
Yes,
That
sir.
means theta is nothing but of your, it is the angle in which the colors of white light are being contained better.
Okay, sir.
So that means VGR, violet to red, this color should be present. That means dou V minus dou R if I do, will I get this total value?
Yes, sir.
This is dou V
Minus
minus dou
dou.
R. So
Yes,
this
sir.
will give
We'll
me
get.
this theta.
Yes, sir.
So I can say that theta, angular dispersion theta is your angle in which all colors of light, in which all colors of white light, all colors of white light are contained. Okay, now
Yes,
that
sir.
means that theta is equals to deviation of violet color minus deviation of red color. Can I write like this? So this is the
Yes,
formula
sir.
of your deviation. Can I write the deviation in terms of refractive index, beta?
Yes, sir.
What is that?
But that's for
Mu
very
of your
small angles.
violet minus 1 into angle of prism A
Yes, sir.
minus mu of your red minus 1 into your angle of prism A. Can you simplify this one? Theta will
Yes,
be
sir.
equal to how much for me? Mu V minus of mu R into your angle of prism A. So this will be the deviation in terms of refractive index.
Yes, sir.
This is in terms of directly deviation. Is that clear? These are important formulas, beta. Deviation
Okay,
is
sir.
nothing but angular dispersion is angle made by the violet color minus deviation of violet minus deviation of red color, or it is mu V minus mu R divided by your area of, sorry, angle of your prism.
Yes, sir.
Okay, na? Sure. Next one is about your dispersive power. Dispersive power. Dispersive power. Dispersive power is represented by omega. Okay, dispersive power is represented by omega.
Omega.
It is nothing but it is your ratio of, it is the ratio of your angular deviation, ratio of your angular deviation to the mean position, to the mean position, to the mean position produced by the prism, produced by the prism. Okay, dispersive
Yes,
power
sir.
is nothing but what, beta? It is a ratio of angular deviation to the mean position produced by the prism. That means omega is equals to theta by your deviation of mean color. So what is the mean color
Yes.
for violet and indigo, beta? Yellow.
Yes, sir.
So theta is nothing but what? Dou V minus of your dou R divided by deviation of yellow, isn't it? So I
Yes,
can write omega is equals dou V minus dou R can also written as mu V minus mu R
into
into
it.
your angle of your prism A divided by mu of your violet minus
Minus
1
1
into
into.
your A and A will get cancelled.
Yes.
So dispersive power is equals to mu V minus of your mu R divided by mu of your LO minus of your 1.
Yes,
So
sir.
this is the value of your omega. Clear?
Yes, sir.
This is also sometimes written as of your differentiation of your mu divided by mu minus 1. Difference kada idi. So it is d mu
Yes,
and
sir.
raskochu. Small changes.
Okay, sir.
Okay.
Yes,
So
sir.
that was about the different terminologies you should remember in the dispersion. So what are the different terminologies, beta? Dispersion of a light means spreading of a light. And for the small angle prisms, the deviation is mu minus 1 into your A. The next one is nothing but of your angular dispersion represented by theta. Theta is angle made by all colors of white light have been present. So theta is equals to mu V minus mu R, or it is nothing but equal to how much, beta? Mu V minus mu R into your A. Dispersive power is represented by omega. It is the ratio of angular deviation, that is theta, to the mean position produced by the prism. That is nothing but yellow. Yellow is the mean color for the violet and red, beta.
Okay, sir.
Okay.
Yes, sir.
Then omega is equals to, simplifying it, we are getting these relations. Clear?
Yes, sir.
Sure. Make a small note, beta. Whenever a light is going through prism, beta, both deviation and dispersion will simultaneously will take place. We don't have a prism which will give me only deviation without dispersion or dispersion without deviation. Clear?
Yes, sir.
So what I can say here, a single prism, a single prism produces, a single prism produces both deviation and dispersion, and dispersion. Okay, I can say
Yes, sir.
that both this deviation and dispersion simultaneously. Simultaneously. Okay, we don't have
Yes.
only deviation without dispersion or dispersion without deviation, beta. Okay,
Yes.
but a suitable combination, but a combination suitable combination of two prisms, of two prisms can give only deviation only deviation or only dispersion or only
Dispersion.
dispersion. Is that clear?
Yes, sir.
Now dispersion of a light will occur because of velocity of light beta, because it depends upon color,
Yes, sir.
isn't it? So if there is a change in color means wavelength is changing. Wavelength is changing means velocity will be changing. When velocity is changing means refractive index is also changing.
Yes, sir.
Clear? Sure. Let us try to go for next one. Combination of your prisms. Combination of your prism. Combination of your prism. First combination. We are talking about your deviation. Deviation without dispersion. Deviation without your dispersion. What do you mean by this one, you see? What is there and what is not there in this one?
So deviation is there, sir. Dispersion is not there.
Okay, that means net dispersion is how much? Zero.
Zero, sir.
Net deviation. Net deviation is not equal to zero. Can I tell like that?
Yes, sir.
So it is a combination of your prism kabatti allow basically. So this is your combination of a prism like this. Okay, and one
Yes,
more
sir.
prism somewhere here, right? Like this. This is a combination of two different prisms. Okay, this is
Yes.
having an angle of a prism A, and the angle of a prism వచ్చేసి A dash. If refractive index of this one is mu, the refractive index of this one will become mu dash. Power of this one is omega. The dispersive power of this one will become omega dash.
Yes, sir.
Is it clear? And this is made up of a glass called as of your crown glass, and this is made up of a glass called as of your flint glass. Clear?
Yes, sir.
Now, when I take the white light is being incident on this one like this. When a white light is being incident on this one, what happened, beta? It undergoes the deviation like
Yes,
this,
sir.
and there will be the deviation like this. Then this will fall on this one, and this will fall on this one. There is deviation without dispersion. That means final ray should only have one light.
Light.
There
Yes,
should be
sir.
no dispersion again. This is a given condition. Actually, prism ganaka leka point, the ray of light might have been gone like this,
Yes, sir.
isn't it? So these two are parallel to each other.
Yes, sir.
So deviation will be equal to what, beta? So deviation means I can write angle made by the incident with the refracted ray. This one is known as of your deviation, isn't it? So
Yes, sir.
deviation in the first prism is how much right now? For me, dou 1. Deviation in the second prism will be equal to how much, beta? With respect
Dou
to
2,
this one,
sir.
that will be equal to your dou dash. With the incident, this is your refracted kabatti. This will be equal to your dou dash, not dou 2 anything.
Okay, sir.
Okay. Now, what is the necessary condition for this one to undergo means I can write here, see. So necessary condition is necessary condition. Necessary condition. So what is the condition, beta? Net dispersion is zero. Dispersion formula, beta? Deviation of violet color minus
Minus
deviation of
deviation of
your
red
red
color.
color, isn't it?
Yes.
Plus in the second prism means this will be equal to deviation of violet color dou v dash minus of a deviation of a red color in this one
Dash.
dou r dash.
Yes.
Must be equal to zero, because for the second prism we are taking everything in terms of dash.
Dash. Yes, sir.
Isn't it? Now can I write this one in terms of refractive index, beta? Mu
Yes,
v
sir.
minus of mu r into your
Into a.
prism is nothing but a, plus
Yes.
this means mu v dash minus mu r dash into your angle of your prism a dash will be equal to zero,
Yes, sir.
isn't it? Now if I take this one on this side, so this will become for me a dash is equals to minus mu v minus mu r into your a divided by, very important formula, beta, mu v dash minus mu v dash minus mu r dash. Can I write like this?
Yes.
అర్థమైందా? So what should be the angle of the second prism which is combining, so that it may have your deviation but no dispersion?
Yes, sir.
Or it may have a deviation without your dispersion. A dash must be equal to mu v minus mu r into your a divided by mu v dash minus of your mu r dash.
Yes, sir.
This is your necessary condition. Is that clear?
Yes, sir.
Now tell me what will be the net deviation. I can write in this situation, net deviation will be equal to what beta? Deviation in the first one plus deviation in the second prism. Ante kada? This dow 1 plus dow dash will give me the net deviation.
Yes,
Antena?
sir. Yes.
Now tell me what is that formula beta? Dow net will be equal to, first prism will be equal to mu minus 1 into A, can I write?
Yes, sir.
Plus second prism will be
Mu
mu
dash
dash minus 1 into
into
A
A
dash.
dash. Yes, sir.
If I simplify this one, this is mu minus 1 into your A plus this one is mu dash minus 1 into A dash. A dash value ఎంత అని చెప్పు? A dash value is minus
Mu
of mu V
mu v
minus of
minus mu
mu
r
R
into
into your A
A
divided
divided
by
by
this is mu V dash minus of
mu
mu
r
R
dash.
dash.
Yes, sir.
Close the bracket. Now you
Yes.
simplify this one finally. So this will become for me how much better? Mu minus 1 into your A. This one is plus minus minus. This will become for me mu dash minus 1 into this one is how much right now here? Mu V minus of mu R into your A divided by mu V dash minus of mu R dash. Any problem?
No, sir.
Now can I take mu minus 1 into your A common, because A is anyhow common?
Yes, sir.
So if I take mu minus 1 also common into your A, so what I need to do here beta? This will become for me 1, divide
1.
by mu
Yes.
minus 1. So this will become for me mu V minus of mu R divided by mu minus 1. అంతే కదా, కామన్ తీసుకోవాలంటే mu minus A
Yes,
anyhow is
sir.
common. If I'm taking mu minus 1 means I need to divide by
Yes,
mu
sir.
minus 1 on both the sides. On the on the both the sides of an equation. That means this will become for me how much better? Mu dash minus 1 divided by
Divided
this will be your mu V dash minus of mu R
mu
dash.
r dash. Yes.
Is that clear?
Yes, sir.
Now see here. So if I write it very carefully, dow net will be equal to mu minus 1 into your A into 1 minus. Now tell me, see, mu V minus mu R divided by mu minus 1 is what better? Mu V minus mu R divided by mu minus 1 is what? Mu V minus mu R. Mu V minus mu R divided by mu minus 1 is what?
Omega,
Omega.
sir. Dispersive count.
So I can write in terms of your omega. So this one is your omega. This is ulta of this one. So
1 by omega, sir.
1 by omega dash.
Yes, sir.
Is it clear? Mu
Yes,
minus
sir.
1 is nothing but deviation in the first prism.
Yes,
So
sir.
I can write
Dow.
dow net will be equal to, this is your dow 1 into 1 minus dispersive power of the first prism divided by dispersive power of your second prism.
Yes,
So
sir.
this is your formula for your NEET examination or mains examination for your competitive track. So dow net deviation without dispersion, dow net must be equal to dow 1 into 1 minus omega by omega dash. Clear?
Yes, sir.
This complete derivation is actually for your board examination beta. But for competitive track, you need to directly remember this one. But anyhow, you should know how you got this derivation. That is the reason I did the complete derivation in detail for you.
Okay, sir.
Okay, now you can keep some points here beta and write it out for this one. Generally or usually, I can say, usually dispersive power of your second prism is greater than the first prism. So deviation is in the same direction as produced by first prism, as prism by your first prism part of a relation. Is that clear beta?
Yes, sir.
Okay na beta?
Yes, sir.
So generally omega dash will be greater than omega. So deviation is in the same direction as produced by the first prism. First prism deviation is the final also will be in the same direction. Okay.
Yes.
Now one more, and this is very important. A prism which produces deviation without dispersion. Deviation without dispersion is called achromatic prism. Is called what, beta? Achromatic prism. This is called as of your achromatic prism. Clear? What do you mean by
Yes, sir.
achromatic prism, beta? A prism which produces a deviation
Without the
without
dispersion.
your dispersion is
Only
known
the
as
white
of your
light will come in.
achromatic prism. Is that clear?
Yes, sir.
ఈరోజు కాలేజ్లో ఎక్కడి వరకు అయింది?
సార్ ఈరోజు యాక్చువల్గా అక్కడ స్టార్టింగ్ లైక్ ద ఫస్ట్ కేస్ చెప్పారు అంతే సార్.
Okay.
ఎస్ సార్. లైక్ వాట్ వి డిడ్ యెస్టర్డే ఈరోజు అయిపోయింది సార్.
అచ్చా, అర్థమవుతుంది కదా ఇది క్లియర్ గానే?
ఎస్ సార్, ఎస్ సార్.
రికార్డింగ్ కూడా ఉంది, నేను పంపించేస్తాను నీకు. నో ప్రాబ్లం.
ఎస్ సార్, ఎస్ సార్, అర్థమవుతుంది.
నెక్స్ట్ వన్, opposite of this one, better right now. Second one, there is your dispersion is there. That means splitting of light is there. There is a dispersion without deviation. That means if there is no deviation in this one, without deviation, that means finally the ray of light is dispersed,
ఎస్ సార్.
isn't it? That means if I am writing the diagram for this one, this is your prism. And white light is being incident on this one like this.
ఎస్ సార్. స్ట్రైట్.
Okay. It will undergoes the deviation like this.
Yes,
And
sir.
one more ray of light will go deviation like this.
Sir,
And
but
this ray of, yes, better.
yeah, without deviation, right, sir? So
Final
internal
ga
deviation will be there, sir.
there will be, yeah, internal deviation will be there. Final ga it will be not there.
Okay, sir.
So there will be red light here, right? And from this one again, this white light is going out like this, and this red light is going out like this. Okay.
Yes.
So what is the mean color in which it is being present?
Okay,
better?
so sir, so the incidence and the final dispersion, they're like parallel, we can say. Right?
Yeah. So this one is actually straight line like this. It was
Yes,
supposed
sir.
to be in a straight line like this. See, now there is a splitting here. Violet is there, isn't it? So here there is a violet. There is violet is there. There is yellow, and there one is your red.
Yes.
Okay. So inside is your red here, and here it is your violet. Dispersive power is omega. Here it is your omega dash. Refractive index is mu. For this one it is your mu dash. Angle of prism is a. For this angle of prism will be equal to your a
Yes,
dash.
sir.
Okay,
Yes,
na?
sir.
Now finally this one will be equal to v dash, and this will be equal to your r dash.
Yes,
Clear?
sir.
Finally it is nothing but r and v. So now what are the condition you tell me? Net deviation is equals to 0, but net dispersion is not 0 because light
Yes,
is
sir.
splitting, you see, finally. So net dispersion is not equal to 0. So what is my necessary condition now? What is my necessary condition? Tell me. What is my necessary condition? Net deviation must be equal to 0, no?
0. Yes, sir.
Deviation in this one is dow 1. This
Yes,
one is,
sir.
say, for example, dow dash somewhere.
Down at is 0.
So dow 1 plus of your dow dash must be equal to 0. This is my necessary condition.
Yes, sir.
Mu minus 1 into angle of prism first one plus of your mu dash minus 1 into your a dash must be equal to 0. So if I take this one on other side, so it is mu minus 1 into your a will be equal to minus of mu dash minus 1 into your a dash. So from this
Yes.
one I can get the value of your a dash, beta. What is the necessary condition? A dash is equals to minus of mu minus 1 into your angle of your prism A divided by mu dash minus of your 1. So this will is your necessary angle of the prism of second, which was required for undergo the deviation without your dispersion. Deviation without any deviation,
Yes.
sorry.
Yes, sir.
Dispersion without any
Deviation.
deviation.
Yes.
Is it clear?
Yes, sir.
Chalo. Now in this situation, what is my condition, beta? In this situation, in this situation, net dispersion is equals to theta plus theta dash. That means theta net will be equal to mu v minus of mu r into your a plus this will become for me mu v dash minus mu r dash into angle of your prism a dash, isn't it? So
Yes.
theta will be equal to how much for me beta? Mu v minus mu r into your angle of prism A plus mu v dash minus of mu r dash into your A dash. A dash value ఎంత వచ్చిందన్న? A dash value is minus of mu
Mu
minus
minus
1
1
into
into
your
A
A
divided
divided by mu dash
by
minus
minus
1
1
into your A.
into. Yes, sir.
అంతేనా? Into A నేనా? కాదు.
A రాదు.
Into mu dash minus 1 only. There is no A like this.
Yes, sir.
Sorry.
Yes.
Okay.
Yes, sir.
Oh, chalo, now simplify this one. There is a minus sign here.
Yes, sir.
So this minus and minus and this will become for me mu v minus of mu r into your a. This is minus mu v dash minus of your mu r dash into this one is mu minus 1 into your a divided by mu dash minus 1.
Yes.
So what I can take common in this one better? Mu minus 1 if I'm taking common again, you divide by mu minus 1 because a anyhow I'm taking common right now here.
Yes, sir.
So this will become for me mu v minus of mu r divided by mu minus 1. Isn't it? This is
Yes.
minus, this is mu v dash minus of mu r dash divided by mu dash minus 1. If you see this one carefully, what is this one beta? Theta net will be equal to dou v minus 1 is nothing but how much? Dou 1 I can write.
Yes.
Into mu v minus mu r by mu minus 1 is what? Omega
Yes, sir.
dash. Omega dash.
Omega dash. Yes, sir.
So this will be your net deviation. Clear?
Yes, sir. Omega dash is great.
అవును కదా, generally omega dash will be greater than the resultant part.
Yes.
Okay, so generally omega dash will be greater than omega. So I can say that the prism which is producing dispersion without deviation is called as of your DVP beta, that is direct vision prism.
Okay, sir.
Prism which produces dispersion without deviation is called direct vision prism. Is called what? Direct vision prism, DVP antam.
Okay, sir.
Okay na?
Yes.
This is about your direct vision prism. Clear? Any doubt in
Yes.
this one?
No, sir.
So by this we have completed complete part of your prisms and their applications. We need to do the problems. We'll try to do the numericals from the tomorrows based upon this one, because this topic is little bit your memory based a lot. You need to take the formulas,
Yes.
keep in your mind, and we need to practice a lot number of your numericals. Then only you can become master on the prism particle relation. So in
Okay,
the
sir.
tomorrow session of a class, we'll start doing the numericals of prism. But before that, I have sent you your assignment of that college material gada. You please try to take out and try to do the prism form problems from that one.
Okay, sir.
Okay na? Undi kada adi material line పంపించింది.
Yes, sir. Akash one, sir.
Okay.
Okay, sir. Yes, sir. Sir, and tomorrow morning, sir, or
Tomorrow
evening
morning
only,
కొంచెం
sir.
నాకు హాఫ్ అన్ అవర్ ముందే రిమైండ్ చేయండి. నేను మర్చిపోతున్నాను. మార్నింగ్ పూట క్లాసెస్ లేవు కదా, లేట్ నైట్ క్లాసెస్ ఎక్కువైపోయాయి నాకు.
Okay, sir. Sir, so then we'll do in the evening only, sir.
లేదు, మార్నింగ్ కూడా పాసిబుల్ చేసుకోవచ్చు, కానీ
Sorry, sir. I'll message you, sir.
you know what is the thing is you try to fix the what do you call that one timings.